And with that, we are ready to begin our event, again sponsored by Sybase and hosted by Information Management. It is my pleasure to introduce our moderator for today, the host of DM Radio and Information Management's webcast series, Mr. Eric Cavanaugh. Eric, with that, I'll turn the floor over to you.
Ladies and gentlemen, hello and welcome once again to the Information Management webcast series. We've been very busy lately and are happy to have you with us today for what is one of the hottest topics that we have at the magazine. And that topic is data modeling. And folks, we're very excited to have Mr. Steve Hoberman with us today. He is one of the most knowledgeable data modeling experts you can find anywhere on planet Earth. And that's why he does a lot of traveling, and he's always quite busy because people know that he really understands his stuff. So a couple quick housekeeping notes, and we'll be off to the races. You can send a question in at any time for our speakers. We'll have 3 speakers today, so don't be shy. Send your questions in using the Q&A component of your webcast console. We will archive this event for later viewing, so if you miss anything, fear not. You can always come back tomorrow or any day after that and check out the archive, and you can share it with your colleagues as well. The archive will be at that same episode URL where you originally registered. So let's move right through some opening slides. There's a slide about yours truly, and enough about me. There is Steve. He is literally the most requested data modeling instructor in the world and has educated more than 10,000 people about data modeling and business intelligence techniques. He's a regular instructor at various conferences, including TDWI, and of course, we're always happy to have him here. He's also written some books. He's offered 5 books, in fact, including the bestseller Data Modeling Made Simple. And I love his email address, me@stevehoberman.com. We're also going to hear from George McGeechy, Metadata Matters Limited. He's calling in all the way from the UK, and he also has 25 years of industry experience, and he is also an author. He co-authored the upcoming book, Data Modeling Made Simple with Power Designer, with, you guessed it, Steve Hoberman. So we're going to hear from him. We're also going to hear from David Dickman. He is the product line manager for design tools at Sybase, so he manages the overall business for the modeling and metadata management of products, including the overall vision and direction of Power Designer. So as I'm sure you all know, metadata and modeling go hand in glove. So we're very pleased to have all these experts. There's just another reminder to ask questions. Please don't be shy. Reach out, ask anytime. We'll save that for the Q&A at the end of the broadcast. And with that, I'm going to go ahead and hand it over to Steve Hoberman. The floor is yours.
Thanks, Eric. Hi, everybody. So we're going to be talking about data modeling made simple with Power Designer. And in terms of topics, I'm going to start off talking about the 6 different types of data models, and then the 3 approaches to building them, top-down, bottom-up, and a hybrid approach. And then I'm going to touch a little bit on normalization and abstraction and show you an example. And then I'm going to turn it over to George. George is going to go through some of the really cool features of Power Designer, including traceability and the enterprise glossary. And to start, we'll talk about the 3 approaches and the 6 types of models. So there are 3 levels of modeling: conceptual, logical, and physical. And when we think conceptual, we think that one-page view. We think, how do I represent an application? How do I represent everything in my data warehouse on a single piece of paper? And the purpose of that view is for scope. So we know what we're going to deliver in a certain project or a program. And once we understand that scope, we move on down to logical, where we focus on the business solution, which is, how do I solve the business's problem without complicating things with technology? So purely looking at the business rules, the navigation paths, what do the users need to get their job done? And then from there, go on to the physical and talk about the technical solution. So how do you take this amazing business solution we created and now compromise it for technology? So we go through these 3 levels. We start at the conceptual, understanding the scope, and then we take that scope and we solve the business's problem at the logical, and then we modify that solution to make it work with our tools. There's also 2 different modeling mindsets, relational and dimensional. And relational is all about modeling business rules, and dimensional is all about modeling navigation. So in a nutshell, that's really the difference between relational and dimensional. Relational is about the business rules. Dimensional is about navigation. And I'm going to go through, so really you have these 6 types of data models. Either a data model is conceptual, logical, physical. Pick one of those, and then either it's relational or dimensional. So every data model should fit into one of these 6 different cells. And I'm going to show you an example of each one. If somebody creates a model for you and it's a relational conceptual, here's an example of a subset of that. We may have some high-level concepts like customer, an account, and account balance. And each of these, they're not logical entities, they're not physical database tables. Each of these rectangles are concepts. They're terms that our business users use in ordinary conversation. And the lines here, because this is relational, represent business rules. So if each account may contain one or many balances, and each balance must relate just to one and only one account, that's a pretty strict business rule. So these relational conceptuals are great ways to explain the business at a very high level. Also at a conceptual, if we look at not just the relational, but if we look more at a dimensional type of model, same level of detail, very high level, just business concepts. But now instead of modeling business rules, we're modeling navigation. We want to know what the users want to see. Okay, I want to see account balance. Well, what do you want to see it by? I want to see it by account, by customer, by month, by region. And what's kind of challenging sometimes is even though these relationship lines look a lot like they did in the relational, they really mean something different. The relationship lines here mean, how do I navigate? So once I see a balance amount at a region level, I may want to navigate up to a certain country. I'm looking at a balance amount for all of 2010. I may want to navigate down to just February 2010. So it's all about just going up and down hierarchies and navigating through these lines. At the next level of detail, if we're looking at the logical and it's relational, this is a pretty formal model. Formal meaning we're actually following very strict rules of mathematics, normalization. So we are going through all our data elements and asking ourselves, where does each data element belong? Which entity should we assign each data element to based on some pretty strict rules? And when you're finished going through this process of applying the rules, you really have a model that represents the business rules at its lowest level of detail. We can take the same level of detail and look at it from a dimensional point of view, and now the elements are shuffled differently. They're shuffled purely for what's easy to navigate for the users. So if someone gives us a 5th normal form design, so it's a highly normalized model, it might be great to represent the business rules, but it may not be so great to represent navigation and reporting. That's where the dimensional comes in. We can easily use these kind of models to show how someone's going to navigate through different levels. If we look at it at a physical level, now we're starting to think about technology. So this is where, even though in this example we're showing business names like account open date or account alias name and that sort of thing, when this becomes an actual physical design, as you see in the note to the right here, all of these business names get replaced with whatever it's called in a database. So for example, instead of account code, it might be account underscore code, for example, or it might be abbreviated account underscore CD or something like that. And here you can see we're kind of modifying these structures to make it work with our tools. So I like to say in my training classes that I hope one day the physical layer would just go away, and we'd wind up with technology that's so super fast that the logical models become the physical models. There's really no need to compromise anything. We're not there yet, but we're definitely closer than we were years ago, so it's a step in the right direction. And then at a dimensional physical level, the most common structure is called a star, or star schema. And here we are showing an example of that, where in the center of the star schema is everything users want to see, like the amounts, like account balance amount and so on. And then in the outside tables, it's what I want to see it by. So things I measure go in the middle. Things I want to see it by go in one of the outside boxes called dimensions. And it's physical because what we've done is we've flattened all of the hierarchy levels, like country into region, year into month, purely for some technology reasons, like performance. So it's much more of a physical design. We're no longer showing the levels of detail we had before. So this is high level, the 6 types of models we're working on. Now, how do you build them? There are lots of different approaches out there. And I thought it would be kind of fun to put all 3 approaches on a single PowerPoint slide. So we have a top-down approach, a bottom-up approach, and a hybrid approach. And this is at a high level, kind of generic. There's lots of more specific ways to do top-down, bottom-up, but this will explain it all in a single slide. Top-down means you're driving the modeling process by looking at what the business needs. What are the requirements? I really don't care about any existing applications out there. Just want to know, what do the users need? And the top-down approach can be as simple as standing in front of a room and sketching ideas on a whiteboard or flip chart, or it could take the form of a pretty formal requirements document. But the point is, it's driven purely by what the needs are. Where the bottom-up approach is driven from looking at something existing, like reverse engineering. Reverse engineering means looking at an existing database and taking it up into a data model or a very high-level conceptual, or looking at existing applications, like databases, interface layouts, and rolling those up as well. And a hybrid means you're doing a little bit of both. You may be doing a little bit of top-down to understand what the users need, and then do a little bit of bottom-up to find out where it is. You tend to see these 3 approaches at a high level. And in the back of your mind, you're probably thinking, okay, which one is most successful? And it's a typical consultant's answer. It depends. It depends on a lot of factors. Depends on what the goal is of the model. Depends on what your starting point is. Do you have a pretty robust set of requirements? If not, you may find bottom-up is working very well, for example. And I also show all 3 on the same slide because it illustrates that they're not that different from each other. That you're using the top-down, the bottom-up, the hybrid, even though they sound very different. You're using all 3 of these just to get to a point when you have a baseline model. Like you're representing what the users need, the audience perspective, using their terms. And then usually there's a modification to the model done to take the audience perspective and make it more of an enterprise perspective. So, for example, you may work with a group of users. They may call something customer, and when you look at the broader enterprise, it may be called client or consumer, or at the highest level, party or person or organization. And then once you have that fit in place with the enterprise perspective, there's a review process and a sign-off. And it's actually my view on the review process and the sign-off is there should be a non-issue here. This should be a formality, because if we did our modeling right, the people who are responsible for signing off on the model helped us build it. So it's obvious that they would be supportive of it. I mean, my recommendation is if you're ever working on a modeling assignment and you feel somebody may give you a rough time on the review or the sign-off, just add their name as an author to the model. And now they can't say anything bad about it because their name is actually on the model. So don't say I said to do that, but it's a good technique if you need to. So, and then keep it up to date, the maintenance part. I put maintenance in here because it's extremely important, and a lot of organizations I consult with don't do this phase as strictly as we should. And one of the issues is a lot of the people who build the models are assigned to a project, and then when that project ends, they're assigned to a different project. There used to be a role called a data administrator, and that role is rare to find in many organizations these days. But that would be the person or the group who would be responsible for maintaining the models. Now it usually falls on the shoulders of a data modeler who's assigned to projects or a data architect. So these are the three different approaches. And I'll show you an example of an actual project I worked on, top-down approach. So I spent many years working for a manufacturing company, and one of the projects I worked on was a project on consumer feedback. So if you were to buy any products from this company and you wanted to contact the company to explain maybe you had a good experience with the product or maybe a not so good experience, you can call a phone number on the back or visit a website and kind of submit your feedback. And I worked with a group of users to design an application where you could track how well feedback is on certain products. And the very first day I was assigned to the project, we had a kickoff meeting, and I stood at the front of the room, top-down approach. I really didn't care what was out there in any applications today. And we just started a discussion by talking about what the users do. And we were sketching ideas out there, and I had a box called customer and another box called consumer. And in my mind, early in this project, I was using them as synonyms. I thought they meant the same thing. And very quickly in the conversation, because we had a user in the room, a key user, she explained what the difference was. We had a really good conversation where we talked about what the difference was between these two terms, and then we documented it, and were able to move on. So that's an example of a top-down approach. It was driven purely by how the business works, what their requirements are, without any regard for the reality, what's actually existing in any kind of system today. I'm now going to talk a bit about normalizing and abstracting. So, regardless of the approach we take, whether it's a top-down approach or a bottom-up approach or a hybrid approach, sooner or later we wind up with a list of attributes or data elements. And you see here a whole bunch of data elements around employee. And the primary key is the employee identifier and the department code. We have 3 phone numbers for the employee, and their name, the name of their department, when they started work, and whether they are vested or not. Vested means, are they eligible for retirement benefits? And if they are started at a certain day in their company, and they're no longer, and they've been there at least, for example, 5 years, then they are considered vested, for example. So it depends a lot on your employee start date. Right away, you're starting from the beginning. I call this chaos because we have no idea we have no idea what entities these data elements should be assigned to. A lot of questions come into our minds. And the way to handle the chaos is to normalize the elements. And with normalization, there's a set of different rules, and they're each named with a number, like first normal form, second normal form, and they each require us to apply stricter and stricter rules to the data elements. So, for example, first normal form, it says move repeating data elements to a new entity. So if you ever have the same data element more than once in the same entity, take it out, move it to a different entity. And if you have a data element that contains more than one piece of information, it's multi-valued, break that down as well. So that's first normal form. When you think about what normalization is, it's really an amazing topic. And when you hear the word normalization, we sometimes get turned off because it's got that techie sound to it. But really, it's just a formal process of asking business questions. You can always tell the data modelers in a room of people by the questions they're asking. They're really going through these same questions in their heads. So normalization is really just the formal process of asking business questions. For example, right away, we're only at first normal form. Think of all the questions we could ask right here. Well, let's see, we have to remove any attributes that contain more than one piece of information. So employee name, should we parse it? Does it contain a first name and a last name? Maybe we should break that apart. How about phone number? Would it be nice to see the country code and the area code distinct from the phone number? What about employee start date? Should we break apart day, month, year? Should we break year apart into year, decade, century, millennium. You can go pretty detailed with breaking these elements apart. What about those phone numbers? I mean, that's kind of strange. I mean, phone 1, phone 2, phone 3, is that really a repeating group? So ideally, as a business person, we can ask to answer a lot of these questions. In reality, what we do as the analyst and the modeler is we try to find the answers ourselves by looking at data. So let's just say, taking this example to the next step, we have several different employees. We have Henry Winkler, Steve Martin, Mary Smith, Bob Jones, and we're told that this is a representative set of attributes. Well, if this is a representative set, looking at this data, are there any surprises? Do you see anything kind of strange here? Look at the phone numbers, for example, phone 1, phone 2, phone 3. Why does phone 3 have the same value for all the employees? Phone 2 has some of the same values. Phone 1 looks like it's distinct for each employee. So by digging in the data a bit, we learn that we really don't have a repeating group. We really have to just come up with better names. Where phone 3, because it has the same value for each employee, is an organization phone number. Phone 2 looks like it varies by department, so we can rename it as a department phone number. And phone 1 looks like it really is unique for each employee, so we can keep that employee or rename it more specifically to employee phone number. Second normal form says make sure every entity on your model has the minimal primary key. So here we have employee and department. If normalization is a formal process of asking business questions, what questions would you ask here? Well, a lot come to my mind, like, can an employee work for more than one department? Can a department contain more than one employee? How do you identify an employee? How do you identify a department? And after getting answers to all these questions, we have a model like you see here, where you have a whole bunch of employees, and it looks like after asking questions or digging deeper in the data, employee identifier identifies an employee, department code identifies a department, and there's an assignment between the two, allowing for an employee to be assigned to more than one department and a department to contain more than one employee. And third normal form says, summarizing kind of at a high level, resolve any hidden dependencies. So if there's any elements that don't depend directly on the primary key, take them out. And the most common modification to our model that third normal form makes us do is take out derived data. So for example here, what questions would we ask? Well, that vested indicator may be derived because it looks like it's based on the start date. So assuming it is, and we'd have to confirm it, we would take that out. And that is a taste of normalization. A bit on abstraction. So abstraction is a logical data modeling process where we redefine data elements, relationships, and or entities into more generic structures. So for example, you may have on your data model some of these concepts like customer, consumer, student, employee, and realize, wait a minute, why do I need all these separate ones? Really, I just have a party, which could be a person or an organization, playing many roles, like Bob could play the role of a student. Bob could also play the role of an employee. And here's an example of abstraction. So I took this out of my data modeling masterclass. There is a customer, a supplier, an associate, and they have several relationships here, one between customer and associate, one between supplier and associate. But really, when you think about customer, supplier, associate, what we can do is completely abstract them to something like a party, and a party playing multiple roles. So where did customer go, for example? It's just another role type code with a description of customer. Same with associate, same with supplier. And all the phone numbers and email addresses go into something called communication medium. All the ways of identifying a role, like their social security number or a DUNS number or a tax ID, go into the concept of an alternate identifier. Then you have party role association, which relates any two roles together. So it might say that Bob, the associate, is the support person for Mary, the customer, for example. And this is one example of abstraction, and there are hundreds of them. You find the more you abstract, the more you have these patterns, like party role, you can plug into different situations. Party role is a very popular one. The main advantage of abstraction is flexibility. You can now handle any kinds of role types. And you can model the world very easily this way. And the disadvantage is you lose everything else. So you lose communication ability, you lose the ability to enforce rules. So it's a very passionate topic among data modelers. When we kind of hang out at our data modeling parties, this usually gets one of the hot topics, like icebreakers, to talk about. So it is pretty exciting. Both sides of the more experienced I find modelers are, the more we tend to get drawn to abstraction. It's very interesting. And with that, I'm going to turn it over to George.
Hello. Thanks, Steve. I'm going to change the focus now from talking about data modeling generally and normalization of those topics to talking about Power Designer specifically. We're going to look at various ancillary topics, let's say, relating to data modelers, business process and XML modeling, using the new enterprise glossary feature of Power Designer 16, and a little bit about using Power Designer to model your enterprise. First of all, let's look at this diagram here. It shows most of the types of model that are available in Power Designer. You'll recognize the conceptual data model, logical data model, and physical data model at the bottom of the diagram. And there are various other kinds of diagrams there that we can have generation links and reuse links within Power Designer. There are some capabilities we're not showing on here, such as the ability to link from any model to requirements model and share business rules, generating objects in various types of models from requirements, creating shortcuts from one object to another model, linking diagram symbols to related diagrams, which could be in any other model, generating reports and Excel extracts, importing from Excel files, and custom object generation. We are going to look at just a couple of the lines on this diagram. One is the link from a logical data model to a business process model. The second is generating an XML schema model from a physical data model. And we'll take that one first. If you look at this slide here, we have two diagrams. The one on the top left is a fragment of a logical data model for recipes. So we have a recipe has steps, and each step has a number of ingredients involved. And we actually have an intersection into there, recipe, ingredient, step. On the bottom right corner, we actually have an XML model showing a potential XML schema containing information about recipes. So it has a recipe element which has steps within it and ingredient steps within those. And we also have a list of unit and measure codes and a list of ingredients. And we've got from the top left to the bottom right by generating a physical data model from the logical, then selecting parts of the physical data model, generating an XML model, and I tailored it a bit. And from this, we can generate the XML schema, which we then hand off to the people who manage our messages. So we've taken that relational model shown on the top left, created a hierarchical model on the bottom right, and we can generate a schema from that. When I generated the XML model from the physical model, I asked the Power Designer to generate mappings between the two models. So we can see here on the left we have the physical data model, and on the right the hierarchy of the XML model. And we can see that, for example, the recipe table was used to generate the recipe element, and we can see that the columns within recipe match. They are mapped to the attributes of the recipe element. The bottom part of that shot there shows a little bit more detail of the actual mappings, and we could double-click entries in there and drill down a bit more. Now, the key thing to remember here is all of this was created by Power Designer. So if we remember, we started with a logical model, then a physical, then an XML model, and Power Designer is retaining all the links between those, and that's important to remember. Now, data models don't exist in isolation. All data is created and consumed by business processes. So here we have an extremely simple couple of processes within recipe development. So we have a process for testing a recipe variant and an approval process, and we end up with a set of approved recipes. Now, obviously, business processes, they access data. And here, in this dependency matrix in Power Designer, we're showing the data accessed by each process. We have 3 data objects, which if you turn your head on its side, you can read them in the column headings. They are ingredient, recipe, and recipe step. And this is a very simple process model. Both processes access all the data objects, but it's usually not quite that straightforward. Here we're looking at how we link one of those data objects to the logical data model. So the bigger one of the 2 screenshots there shows the general tab on the property sheet for the data object called ingredient. If you look at the bottom left-hand corner of that, you can see that it says type structured data. We are saying here that the idea of an ingredient is not just one single piece of data. There's a whole structure behind that. And what you can't see behind the select an object part of the panel there is a shortcut button, which I've clicked so that I can select an entity to represent I've selected an entity which actually contains the structure of the ingredient object. If my data object is an elementary data instead of structured, I can instead link it to a data item in a conceptual data model. Either way, when I make these connections, I'm now connecting the business process model to a data model, adding it to the end of the chain of data models. Now we can see that traceability here. What I've done here is I've opened up the definition of the recipe element in the XML model and run the impact analysis from it. And it is tracing all the way through from the recipe element here through the mapping to the physical data model down to the table, and then following the generation link from the table to the entity in the LDM that it came from, and then following the link to the data object that I have linked it to in the business process model. And if I choose to expand this dialog a little bit more, I can even see which business processes access that data and whether they create, read, update, delete, etc. If you choose to, you can make a more direct connection from the BPM to the XML model. For example, you could link the XML model as an input to the approved recipe variant process. So you could actually represent that this is the message that represents the data coming into this. So we're seeing here a chain of objects all the way from the data object in the process model down to the XML element. Power Designer also maintains those links at model level as well. So here I've got all these models in the Power Designer idea of a project. And on a project diagram, I can see there are 4 models. There are generational reference or mapping links between those 4 models. And these links are all created automatically by Power Designer. So I've laid out the diagram myself, because normally it would be laid out the other way up, but I wanted to make it match the shot on the left. So that's connecting business processes and XML schema models to our standard data models that Steve was talking about. Let's go on to now the enterprise glossary. Have you ever created a project, departmental or enterprise glossary of terms? Do you still use it? Does anybody use it? The chances are it was a fairly local thing. then it's history now. It's probably a simple spreadsheet, a document, maybe even a web page. When you have such glossaries, it's a bit difficult to use them actively when modeling. You just have to look things up, make sure you use the right words. Probably somebody writes a script to check words against a spreadsheet, something like that. Well, with Power Designer, the glossary is not merely documentation. In Power Designer 16, we now have a glossary of terms which allows you to follow naming conventions, enforce naming conventions if you want to. That allows you to create cross-reference definitions with the organization's semantics. The validation goes into the model check, standard model check facility, so you can check the words used in object names and codes against the glossary. And we'll see a couple of examples of that later. Now, the glossary is automatically shared to all users of the repository. You can start off from scratch if you like, have somebody type in all the entries, but you've probably already got something you can load in, maybe an Excel document or load it in as a Word document. There are various ways of doing it. You may even have conceptual data models that you want to use as the source of your glossary. The scope of it can be as narrow or as wide as you like. At maximum, I suppose, it would be represent all the words you could possibly use in any of your object names, your model names, your diagram names, if you want to have that degree of control. It's very likely that you'll just start off with defining the key business semantics, like what is an ingredient, the definition of customer and the definition of consumer, as Steve described. It's really important to know the distinction between them. So you can populate the glossary with the verbs and nouns and their synonyms you discover during analysis. So if we switch Steve's example, we may say that we're going to use the word customer, and if anybody uses consumer, that's a synonym, and they should be persuaded or told to use the word customer instead. Here's an example of an enterprise glossary. There are two views shown here. The one on the left is just a very flat list of all the business terms in the glossary. And I've expanded the hierarchy to show that some of these terms have synonyms. So customer, for example, has synonyms of client and consumer. And on the top right, we have grouped the terms by category. So there is actually a customer category within the party subject area category. And within that customer category, we have, it's a very simple model, this one, we have the customer term. You can use these categories any way you like. They could represent subject areas, ownership, levels of abstraction, whatever is meaningful and useful to you. One way you can use them is to manage access to the definitions that within the category, which will be helpful. I'll explain that in a minute when we talk about the composer license. Now, all the entries in this glossary were imported from Excel, and there's a little fragment of the Excel spreadsheet there. So, as I mentioned earlier, we can create a glossary quite quickly. If you have the Excel import definition that I used, you could create this glossary within 1 minute. Okay, 3. In a model, Power Designer model, in the model options, you can select in the naming conventions whether or not you want to use the glossary in that model. So if you say, yes, I do, as you type the name of a new object, it will look at what you're typing and suggest terms from the glossary. So here I've typed the word consumer, and it says, well, I found the word consumer in the glossary, but I reckon you should be using the word customer. If I just accept that, it will use the word customer instead. It will also, at that point, make a link from this object I've just created to the term in the glossary, and you can see that link from both ends. On this slide here, we can see both ends of that link. If you look at the small part on the left-hand side, we're looking at the term properties. On the Dependencies tab, we can see that this term is used in the name of the entity account balance. The term is called account, and you can see obviously how that's used in the name of the entity, account balance. If my entity was called holding, say, a balance, maybe I defined holding as a synonym of account, it would also be linked through to the term account. The other little screen snapshot there shows the other end of this relationship. On the Dependencies tab for the entity, we can see that it is linked to the two terms, account and balance. And I've customized a list of properties here because I'd quite like to see the description of those two terms, so I don't have to go anywhere else to find it out. So it's following that link and pulling back information for me, which I think is really great. Oops, too heavy on the clicking there. So, and so using the terms glossary to help me decide the object names, I can also use those terms to validate names in my model around that object. So I can
George,
decide
I
whether
think we've
particular
lost
errors
your audio here. Hold on.
Why don't you go ahead and mute his line?
Yeah, hold on one sec here. George, if you can still hear us, it looks like your audio is breaking up. Give me 1 second here. And Eric, why don't we go ahead and try dialing out to George?
Yeah, let's bring in David Dickman while we're waiting to do that. David, are you out there?
Yes, hello. This is David here.
Hey, David, how are you? While we're trying to get the audio connected, I know we have a few good questions here already. I figure we might as well make good use of the time. Do you want to answer a couple quick questions?
Sure, let's go ahead.
So one of the good ones I see here asks, may I please know the difference between a data modeler and a data architect? That's a pretty good question. What do you think?
Sure, and actually that's probably a good one for both myself and for Steve to answer, but I'll take a first stab at it. The big difference we see between data modeler and data architect is when we start talking about architecture, we start thinking about what we see as the enterprise focus on data. So a data modeler is focused on the implementation of a data schema for a given project or use case, a given data warehouse for analytics, or a given database store for a given application or system or project. Where the data architect is looking at all of those different systems and all of those different projects and thinks, what is it the business needs to leverage from this information as a business asset? And we see that typically makes a difference between somebody who is implementing data systems for a given use case to thinking about what is this data for all use cases so we can integrate and federate it more effectively and truly deliver on the promise of decision support and information as a business asset. Steve, do you have anything you want to add to that?
Yeah, David, that was excellent. Yeah, I agree 100%. The data modeler is the person who's assigned to the project, and the data architect takes more of this holistic program perspective. And that's the way I've seen it in a lot of the assignments I've worked on. I noticed, too, it's very interesting. I don't know if you've seen this, too, David, but the term architect kind of morphs into different definitions depending on an organization, too. So they may start with this higher-level view, and then architect might deal more with application architecture or process architecture. So, but in the most general sense, it's exactly that. It's a difference between a project and a program.
Absolutely.
Yeah, we've still got some issues there. And by the way, folks, one thing I forgot to mention at the top of the hour is that, as you may have seen in the Evite, the first 50 attendees are going to get a free copy of the book. So we're very pleased to inform you of all that. And for those who do not get a free one and still want to purchase it, there's going to be a discount code that we're going to include on one of the last slides here. So keep your eyes peeled for that. And, okay, I'm hearing that maybe we've resolved our audio issues. Let's see if we can get them back online there.
Hello, can you hear me?
Hey, George.
Hello.
Much better.
I'm sorry about that. Technology let me down. Okay, back onto this slide. We're talking about the enterprise glossary. What I showed you before was using the terms of the glossary to help me decide what the object names should be. I can also use the terms of the glossary to validate the names of my model using a model check. Here, you can see the results of a model check. The red icons on the left tell me that these things are errors, and the little yellow triangle tells me it's a warning. This is saying It's telling me that I'm using synonyms or glossary terms, but that's not actually an error. Now, I may decide that in my environment, that is actually an error. I'm not allowed to use synonyms. So I could change the severity of that message. The impact of that would be that I cannot generate a new model from this model till I fix that error or turn the error checking off. Whether you do that or not depends on what your environment, your organization thinks is the best approach. It depends quite how tough you are being with your glossary at the time. So it's great having an enterprise glossary of terms, but who looks after them? Is it going to be the data modeler? Well, using the new Composer license in Power Designer 16, you can delegate responsibility for the definitions of terms and other objects to the right people. You can allow them to revise definitions via the web portal. They don't need Power Designer themselves. So this spreads the participation across a wider community of users. Lets people take responsibility for the things they really are responsible for. If you want to know more about the glossary, Matt Creason from Sybase will be doing a deeper dive, as he calls it, into the glossary during the Blueprint TechCast on November the 10th. So if you go to this URL, sybase.com/Blueprint TechCast, you can register for that. It may or may not be open yet, I'm not quite sure. We're now on the final topic for today, which is using Power Designer to model your enterprise. We're not really going to be covering enterprise architecture models here. It's a brief look at some of the ancillary things, but you'll see what I mean. You've seen this diagram before. I showed you it earlier. It's showing data models and various other types of models in Power Designer that can be related to them. Down the bottom we have, as I said, conceptual, logical, and physical data models. Now, Power Designer, Sybase refer to the capabilities of connecting models and objects together as link and sync. The box surrounds those capabilities that are most relevant to a data modeler. So let's extract them from this diagram. This is what I call the chain of data models. So we have the conceptual, logical, and physical data models going from left to right. If you remember what Steve was talking about earlier with his bottom up and top down, I've replaced bottom and top with left and right. So if we turn that diagram on its side and arrange it slightly differently, we have the pyramid view, which appears in our book. We're not the first to use it by any means. Quite a few people I've come across have used the pyramid to represent a hierarchy of models. We have top-down described on the left and bottom-up described on the right. And within these layers, we have the little double-headed arrows showing the link and sync connections from layer to layer. One new feature in Power Designer 16, as well as sharing a glossary, you can share a whole set of reference models. So you can create a library of reference models that are available to all users of the repository, and they're just pushed out to those users. Now, the objects in the reference models, you could replicate them in your data models. You could generate models from the reference models. You could take copies of them. There are various ways you could make use of these models. And note that we have an Excel spreadsheet in here as well. We're not restricted to just Power Designer models in this library. One good way you might want to use this is perhaps you have a model with all your standard domains in. You can share it that way. If you generate those domains into other models or replicate them in other models, you can use the Power Designer synchronization capabilities to keep them in sync. And the last thing I want to briefly talk about is the idea of frameworks. So just to help you manage your models, know what you're doing, providing brief, simple workflow. Here is the Federal Enterprise Application Framework that's supplied with Power Designer 16. If you look at the browser view on the left, there's a project called Project 3, which contains a number of models in folders. All of those folders were created when I created the project. They were all created automatically. The models have all been created by right-clicking one of the cells in the matrix and choosing an action. So in the cell we've got highlighted, list of business objects, well, there is an action there to create a list of business objects. And what that actually did was create a conceptual data model called high-level entity with a diagram in it, and each business object I created in my list became an entity. The semantic model I created by right-clicking the semantic model cell and saying, turn this list of business objects into semantic entity, and on down the chain. So there is here the capability of providing a simple workflow to help you manage your Power Designer environment, to link your process data models and your enterprise architecture models to each other. If you decide that you need to link one kind of model to another kind of model, you can create an action in the matrix to simplify the creation of this and to make sure that people follow standards. Well, that comes to the end of my section. We've covered all of these. And now it's time for me to hand over to David. David, are you there?
Yes, thank you, Steve, and thank you, George. Steve, it was excellent. I thought you gave us some great things to think about on the idea of relational versus dimensional models and the purposes for each, the whole idea of going from the broad scope of the conceptual down to the detailed, denormalized, technology-centric physical, and the reasons for keeping that business focused on data separate from the data implementation. And with George, thank you for showing us how Power Designer can address that, not just talking about some of the standard things we do with data models, but expanding that into XML and the business glossary and some other things that Power Designer as a tool can do to support what's going on. So at this point, I think we should start addressing some of the questions, and I know we have a few good ones here in the Q&A section.
Okay, good. And I guess I'll throw these out to Steve, and then anyone else who wants to jump on, please feel free. We have a lot of really, really good questions. So let's start with some of the easier ones, Steve. Who owns the glossary? Does ownership reside within the business or within the data architecture?
Well, that's a very interesting question. Yeah. And, who owns the glossary? Ownership has to be somebody on the business side. It doesn't mean, though, that there can't be a facilitator, somebody responsible for the documentation and maintenance of the glossary, but the ownership of the glossary must be from the business.
Okay, that's a good, quick, concise answer. So here's more of a technical one. Should XML schemas be defined from logical model or physical model? Probably both. PDM and XML schemas should be mapped to the LDM. This allows the physical storage to be independent of logical relationships?
Yeah, definitely. So on that slide that we had earlier, which showed the 6 different cells, and it had the 3 levels of detail, conceptual, logical, and physical, the XML piece goes right at that physical layer, and it's a great idea to have a distinct logical model from that. It's a very interesting topic. I get emailed questions every once in a while, and that one is one that comes up quite frequently, which is, here's a whole bunch of XML schemas. How do they fit within all my other data models? And a lot of times we spend looking at an XML schema and then reverse engineering it up into a logical model. So it needs to be distinct from the logical.
Okay, good. And this is a question probably for David. It's very specific. Does Power Designer provide a method to tie ETL business rules into the data model so that you have a true source-to-target understanding of the data? In other words, what it is, where it came from, and how it got to the physical data model.
Absolutely. So when we talk about heritage and lineage with Power Designer, we're talking about it from 2 different dimensions. So one is certainly this physical dimension where we have physical model representations of sources, physical modeling representations of interims and targets, and then we have the transformation layer in between. So Power Designer's data movement model and Power Designer's data mapping editor allow us to build those traceability metadata elements into the tool directly, put it all into the repository so we can have that heritage and lineage. Where did the data come from? Where does it go? But we also add the dimension of the heritage and lineage when it comes to data definition. not only do I understand where it came from and where it went, but I also can say what logical and conceptual elements does that relate to? What terms in the glossary does that relate to? What requirements and what business rules does that tie to? So that we can have this idea that this is the data, we understand what it means, and we know why we're using it for this data transformation or integration or analytics.
Okay, good. And lots of great questions here, folks. Thank you so much for the details. So here's another good one. Steve, I'll throw it out to you. Can you link new elements that are identified during more detailed level of analysis? For example, a new entity in a logical model that is not represented in a conceptual model. How do you link this new object to the more general conceptual area where it belongs?
Yeah, now this one, when I hear the word link, I'm thinking this might be a Power Designer specific question. So I'm going to defer that to either David or George on this one.
Sure. So George, do you have some thoughts on that?
Yes, you can generate. You can hear. I'm hoping you can hear me. Okay. You can take the entity from your logical data model and generate it into the conceptual data model that you're using, or possibly, generation actually is the route to go.
Okay, good. And here's another good one, Steve, and maybe David or George. Are conceptual many-to-many relationships resolved in the logical or the physical data model with Power Designer?
Well, I know from a modeling point of view, in the logical model, the many-to-manys need to get resolved. And the conceptual, you can have them. By the time the logical is done, they need to be resolved.
In a Power Designer logical model, you can enable or disable many-to-many relationships. If you have them disabled, when you generate a logical data model from a conceptual data model, then many-to-many relationships are automatically converted into two one-to-manys and an entity. If you have a logical model with many-to-many relationships in and then you disable them, they automatically get resolved. You might not like the name of the entity that's created as part of the resolution, but you can go in and change that. You don't have to make it yourself.
Mm-hmm.
So I think the idea is it comes down to a matter of philosophy and what the logical model is representing. In the classic sense, the logical model is meant to represent the relational logical data model following relational theory, assuming it'll ultimately be a relational database. The logical data model can be hierarchical as an XML canonical data model for messaging or an OO domain model for OO structures. But as a relational logical data model, relational theory doesn't allow for many-to-many, so they'll typically be expected to be resolved. But in a practical world, we also recognize that the logical model is also doubling as a bit of a business concept model, and in that case, the link tables that show up to rationalize those many-to-manys into something that a relational structure can understand can be considered superfluous, and that's why the option is there.
Okay, good. Here's more of a generic one, but still a very good question to ask. I'll throw it out to you, Steve. Data administrator versus data steward. Can you explain the differences?
Oh, okay. So data administrator versus data steward. So there are differences from an organization point of view, and there's differences from a functional point of view. From an organization point of view, the data steward is typically somebody in the business professional side of the house, where the data administrator is someone more on the IT side of the house. From a functional point of view, the data steward is the person who is responsible for a certain section of business data, like customer or product or account, where the data administrator is responsible for the maintenance, the administration in the systems and the catalogs. It's almost similar to the earlier question where you're distinguishing the data modeler from the architect. It's a different focus. So the data administrator is someone who would, for example, keep the data models up to date. The data steward would be someone who actually has ownership for everything a responsibility for everything in the customer area.
Okay, good. And we're going a bit long here to get to some more of these questions. We'll do just a couple more, folks, and then we'll be sure that we pass on all your questions to the presenters today so they can follow up with you directly, because they're all really, really good questions. So let's see. Here's a question about the book. So, Steve, Steve, maybe I'll throw it out to you. Is there a learning curve required for this book if you have not used Power Designer before, or do you think that it's valuable even absent that knowledge?
Yeah, it's actually, the book is written, so it assumes you have no prior experience with data modeling or Power Designer.
Okay, good.
Yeah.
Good. Okay, and here's another one. Maybe this will be the last one. Isn't it true that not all entities in a logical data model need to be present in a conceptual model since the CDM is more high level?
Oh, without a doubt. Yeah. You may have, as David was explaining, kind of the logical and the many-to-many discussion that we had, you can have quite a few entities, the logical, that roll up to entities on a conceptual. So, for example, on a conceptual, you may have an entity like customer, where on a logical you may have customer type could be a separate entity, customer dependence and preferences. So there's definitely a one-to-many, where one concept sometimes could relate to tens or 20s of different logical entities.
Okay, good. Well, folks, you can see more information about the book there. Like I said, you will be contacted if you are one of the lucky 50. We had quite a huge audience today. Thank you so much for your time and attention. Big thank you to all of our friends at Sybase for allowing us to bring you this content free of charge. And a big thanks to all of you folks out there for your time and attention. We know that time is money, and there's a lot to do out there in the world of data modeling. So thanks again, folks. We will archive this webcast. You can check out the archive usually within 24 hours at that same episode URL. But otherwise, we'll hope to catch up to you next time, folks. Take care. Bye-bye.